of the definition by I. Say this is our definition of imaginary numbers. I squared equals -1. If we multiply both sides of the definition by I, then this equation would become I cubed equals -1. So if we multiply this by I, then if we multiply both sides again of this equation, this one by I, then this would become I to the 4th equals -I squared, but I squared is just equal to -1, so this is equal to the negative of -1, which is just equal to 1. Therefore, I to the 4th is just equal to 1. So multiplying again by I gives, okay, we multiply this by I, this gives I to the 5th equals I. And one more time, we multiply again this expression here by I, then we get I to the 6th, I squared, which is just equal to -1. So I to the 6th is equal to -1. And if this pattern continues, we see a cycle forming, and the exponents on I change, and then we cycle through simplified answers of I. The cycle goes like this: I, -1, -I, and 1. As there are 4 different possible answers in this cycle, if we divide the exponent by 4 and consider the remainder, then we can simplify an exponent on I by learning these values, 4 values here. So we call this as the cyclic property of powers of I. You write that down. Cyclic property of powers of I. So we can write that as I to the 0 is 1. We can start with 1, because any number or any variable raised to the power of 0 is just equal to 1. And then I is just equal to I. Then I squared is just equal to -1. And then I cubed is just equal to -I. So let's try solving some problems here. Let's say we're given I to the 35th. Our exponent here is 35. So by using the cycle property of I, we can divide the exponent here